Lesson 6.4. Use inverse functions. Sometimes you want to do the opposite operation that a given function or equation gives you. So to do the opposite or undo the operation, you need to do the inverse function. The inverse of multiply is divide. The inverse of add is subtract. The inverse of squaring would be square rooting. So, properties of inverses. An inverse is when the x and y values are switched. All the x values become y values, and all the y values become x values. Graphically, it's reflected of a line y equals x. So here's a graph. There's the line y equals x. So the inverse is reflected over that. So every point that, say, this one's that far, that its corresponding point's the same distance away on the other side. You can use the horizontal line test to determine if the inverse of a function is also a function. If a horizontal line can touch a graph more than once, then the inverse is not a function. So the yellow graph fails the horizontal line test, meaning its inverse is not a function, and the inverse, you can see, is not a function because it fails the vertical line test. Two functions are inverses if and only if their compositions equal x. So f of g of x equals x and g of f of x equals x. Remember, a function is when one x value gives you only one y value. So lines are functions, quadratics are functions, square roots, however, are not functions because you get that plus and minus thing. So verify that these are inverses. When it says verify, that means that they are inverses. You just need to show the work. So we will go f of g of x. So we're going to start by plugging g into f. So it's 6 minus 2x, but x is the entire other function. So the 2 and the 2 cancel out. The times 2 and the divide by 2. Oh, look, I have 6 minus 6. That's nothing. And then I have negative a negative x. That's what we were supposed to get was x. All right, now we're going to take and we're going to plug all of f into g. So it's 6 minus x, but x is the entire other function over 2. So 6 minus the other function over 2. We have 6 minus 6, which is nothing. And minus a negative 2 would be 2x on the top. Oh, the 2's cancel, and you have x. So we have now shown that they are inverses because both f of g of x and g of f of x equal x. When it says verify they are inverses, that is what you need to do. Other instructions will say find the inverse. So to find an inverse, you switch the x and y coordinates. If the function is written as ordered pairs, then you just switch the x's and the y's. For example, what are the inverse of that? Well, the inverse, which would be f to the negative 1, that little negative 1 exponent means inverse. If it's on a function, it means inverse. And just switch the x and y's. So those flip around, be 3, 2. Those flip around, be 5, 4. There we go. We have our inverse. So let's do one that's more interesting. If it's written as an expression such as that, You think, why do we have that? Well, x to the 4 plus 2, when we graph it, looks a lot like that. That fails the horizontal line test. So the inverse is not a function, but we would like the inverse to be a function. So we are just going to pick the part where the x is less than 0. So we're just going to pick that part. That part is a function. So that's why we have x is less than or equal to 0. All right, so you start by rewriting the f of x as y. So all that happened is became a y. If it's already y equals, then you just skip that step. And then you switch the x's and the y's. So the y becomes x, and the x's become y's. And now you solve the equation for y. So we subtracted 2. And then we're going to have to do the fourth root. When you do a fourth root, it's an even root. You have to remember the plus and minus. But we know that y is less than 0. So if it's less than 0, that's the negative. So we really only have the negative. If it was y was greater than 0, then we'd only have the positive. And that makes it a function. Rewrite the y as f to the negative 1 of x. And that is your inverse. That's all for today. Oh, before I completely sign off, if the exponent was odd, when it's even, you have this x is less than 0 or x is greater than 0. If the exponent is odd, it is a function probably already, and you won't have this little x is less than 0. It'll just be the function. All right, that's all for today. Have a good day.